In today's lecture, we'll look at three common types of functions, their graphs, and some properties about them. So the first one we've already seen before, and these are linear functions of the form f of x is equal to mx plus b. And we've seen this form before. This is the slope-intercept form, where m is the slope and b is the y-intercept. And we've seen there's two special cases for these functions. The first one is when f of x is just equal to some constant c. So there's no x involved here. And this just looks like a horizontal line at whatever value c happens to be. And we call this the constant function. The second special case is what we call the identity function. And it's actually very useful when working with functions. And it's quite simple as well. It's just the function f of x is equal to x. Whatever you set equal to x, that's also what the y value is. And so this is the linear function with a slope equal to 1 and a y-intercept of 0. So what can we say about linear functions? Well, their domain is all real numbers. We can plug anything into it and we'll get a number out. If the slope is non-zero, then the range is also all real numbers. The x-intercept we can find right away with the formula of negative b divided by m. And if it's an x-intercept, then the y had better be 0. And the y-intercept is 0b, which is why we call it slope-intercept form. And this functions will be always increasing if the slope is greater than 0, always decreasing when the slope is less than 0, and constant when the slope is equal to 0, and it's a horizontal line. Now if we want to sketch the graph of a linear function, it's best to just plug in the values negative 1, 0, and 1, and that gives us a good enough idea of what the picture is. So let's try it. We'll make our chart, and we'll plug in negative 1, 0, and 1 for our function f of x is equal to negative x plus 4. So the y value is negative 1 plus 4. A negative of a negative is a positive. So this becomes 1 plus 4, which is 5. Now let's plug in 0. And we'll get 0 plus 4, which is 4. And when we plug in 1, we get negative 1 plus 4, which is 3. And remember here we can see that our y values are decreasing by 1 as we move to the right 1, since the slope is equal to negative 1. That's exactly what the slope tells us. And with this, we have a good enough idea of how to sketch the graph of a linear function. We'll just label our points here. And we might have to add in a little bit more for the y-axis. Alright, so we'll plot down our 3 points. Negative 1, 5. 0, 4. 1, 3. And then we just draw a straight line that passes through those points. And we've got the graph of a linear function. The next example is what we call the squaring function. And again, we've probably seen this before. It's just the function f of x is equal to x squared. And its domain is going to be all real numbers, which we can abbreviate in an interval of negative infinity to infinity. Its range is all negative real numbers, all non-negative real numbers, which is the points 0 to infinity, and we include 0. This is an even function, which we saw before. It's increasing from 0 to infinity. It's decreasing from negative infinity to 0. And since it's an even function, it should be symmetric to the y-axis. And we'll have one relative minimum at the origin of 0, 0 here. So let's sketch the graph now. And when sketching the graph, we want to use a couple extra points since this function's a little bit harder to use. So we'll add on negative 2 and 2. And then that should give us a good idea of what this function looks like. So our x values are negative 2, negative 1, 0, 1, 2. And the y values are negative 2 squared, which is equal to 4, negative 1 squared, which is equal to 1, 0 squared, which is equal to 0, 1 squared, which is equal to 1, and 2 squared, which is equal to 4. And we can see the even function appearing here. No matter if I plug in 2 or negative 2, the y value is the same. And with these points, we can graph it. So we'll mark our x-axis, negative 2, negative 1, 1, 2. And then we'll go up to 4 on the y-axis. And we have our points, 0, 0, negative 1, 1, and 1, 1, negative 2, 4, and 2, 4. And now we'll make this U shape that looks like the following. Oh, well, let's try once more and make it a little bit less ugly here. There we go. And as it goes on, it should go up higher and higher, faster and faster. Since we plug 3 in there, it already gives us the y value of 9. And again, we can see very nicely the even function appearing here, since it looks like a mirror image across the y-axis. And we can see this relative minimum at the point 0, 0. The third function we'll look at is another simple one. It's called the cubic function. F of x is equal to x cubed. And it has similar properties. The domain is still all real numbers, negative infinity to positive infinity. The range is also all real numbers, negative infinity to positive infinity. And we add on these negative numbers since this is an odd function. So we're going to be dipping below the x-axis and picking up more points. And what's nice about this function is that it's always increasing. It's never decreasing. And since it's an odd function, it should be symmetric to the origin. When we sketch the graph, we should use the same points as for x squared, so we can see an idea of the shape here. And so we'll make our chart, and we'll sketch it down and see these properties on the graph. So negative 2 cubed is equal to negative 8. Negative 1 cubed is equal to negative 1. 0 cubed is equal to 0. 1 cubed is equal to 1. And 2 cubed is equal to 8. And again, we can see the odd function sort of showing up. When x is 2, y is 8. And if we look on the negative side at negative 2, the y value also flips over to be negative 8. So let's sketch this one down here. And we might have to make our y-axis a little bit tighter so we can actually get 8 values down. So here's negative 1 and negative 2 for our x, and 1 and 2. And then 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And we'll label those since we'll be using those points. And now let's throw down our 5 data points. Negative 2, negative 8. -1, -1, which is right here. Let's draw the -1 again. Then we have 0, 0, 1, 1, and 2, 8. And this will look like the following graph. We'll pass through our data points and then kind of slow down once we get close to 0, 0, and then gradually speed up until it shoots upwards very quickly. And again, it should be rather fast since 3 cubed is 27. And we can see the odd symmetry happening here. How about in green? If we follow a path from the origin point out to 2, 8, then we can reverse that path in the negative direction and get down to -2, -8. And it's also on the graph. And we can see here that it's an odd function. The domain and range should be all real numbers. And that's it for the cubic function. So in the next lecture, we'll talk about 3 more functions, and those will be a little bit more fun to look at. But that's the end of this lecture.